Hey Calculus, I've had some requests to go through this assignment, so that is what we're going to do. Alright, so the first thing, example number 1. The limit as x approaches 4. Put a vertical line through this x value right here. Here is 4 on the x-axis. When you're finding a limit, you trace the graph. And it has to be a good date. The left and the rights have to meet in the same place. So I'm going to trace the graph coming at that vertical line from the left. Here I am. I'm getting towards that line. There I am. It's coming in at a y value of 7. So my left limit is 7. If I trace that graph coming from the right towards that line, hey, I'm also coming in at 7. So the left and the rights are the same. The limit is 7. All right, it has to be a good date. You have to meet in the same place. Now, you'll notice that there's a hole right there. Can there be a limit at a hole? Absolutely. Just kind of think about you're holding hands on your date over that pothole. All right, let's go to part B. Now, we are approaching -2 right here. So I'm going to put a vertical line through -2 right here. There is -2 on the x-axis. So, trace the graph. From the left, I'm coming in at a y value of 5. From the right, I'm coming in at that same y value of 5. So the limit is 5. The left and the rights are the same. Again, there's a hole there, but there can be a limit at a hole. It's still a good date. You're still meeting at the same place. All right, let's keep going. Okay, part C, we're approaching +2. So I'm going to put my imaginary vertical line through 2. Right here. All right, so I trace my graph coming towards that line. Now the y value is in there at 6. From the right, the y value is also in there at 6. They're meeting in the same place. It's a great date. My limit is 6. All right, now 4. Part D. When you see f of 4, there's no word limit there, so you're not tracing the graph anymore. You're looking for the y value at 4. When x is 4, what is the y value? You're looking for the point. All right, so if we go over to 4, the y value, the point is right here. Here is the point. All right, so the y value is 2. The point 4, 2 is on the graph. So f of 4 is 2. All right, same thing here. F of -2. When x is -2, what is the y value? So we go over to -2 right here on the x-axis and we look for the point. There's the point. The y value is 3. All right? -2, 3 is a point on the graph. F of -2 is 3. Okay, the second example, the middle example. FYI, these were all supposed to be approaching -2 from the left, -2 from the right, -2, -2. They were all supposed to be -2. I think on one of the first worksheets I posted that was not in there yet. So that is -2. Okay, so we need a vertical line through -2. Okay, so right here. This right here is the notation for a left limit. See that little minus sign in the upper right corner? That is a left limit from the left side. That is the left side. So we only trace the graph coming from the left. All right, right here. That y value is at 0. So the left limit is 0. Now when we get to part B, x is approaching -2 from the right. There's a little plus sign. That little plus sign means from the right side, a right-sided limit. So now we trace the graph coming from the right. This is the piece of the graph coming towards that vertical line at -2 from the right. But now it's coming in at a y value of -2. All right, so the right limit is -2. Okay, so that is a bad date. The left and the right are not equal. So the limit at plain old Joe -2, D and E, does not exist. All right, it's a bad date. You're moving in different places. In order for the limit to exist at plain old -2, the left and the rights have to be the same. Okay, part D. what is the y value that corresponds with -2? So you can kind of see there is a little point right there underneath that -2. It's hard to see, but the y value is -1. If you didn't see it, don't worry about it. It is -1. All right, there's example number 2. Okay, third example. The first limit that we're approaching is -3 from the left, so I'm going to put my vertical line through -3. Okay, as I trace the graph, coming towards that line, I'm up here at a y value of 2. So the limit as x approaches -3 from the left is 2. Right here, x approaches -3 from the right. There's a little plus sign. So now I come towards that line. I trace the graph coming towards that line from the right, and I'm still up there at 2. So the right limit is also 2, and that's a great date. The left and the rights are meeting at the same place. So the limit as x approaches plain old -3 is 2. All right, now f of -3, we want the point. There is no point here anywhere. So that point, DNE, there's no point. All right, next one, f of 0. We're looking for the point at 0. Here's 0 on the x-axis. There's the point. The y value is 3. All right, if you notice, the point 0, 3 is on the graph. So f of 0 is 3. All right. Okay, next up, we are approaching 0 from the left. So I'm going to put in my vertical line through 0. All right, so 0 from the left. This is the piece of the graph that's coming towards that line from the left. So the y value is right at 0. Coming from the left towards that line at 0, the y value is also 0. All right, but now we want x approaching 0 from the right. So now this right here is the piece of the graph that's coming towards that line from the right. And that y value is up there at 3. Okay, so the left limit is here at 0. The right limit is up here at 3. So the limit at plain old 0 right here, DNE, because the left and the rights are not the same. DNE. All right, next one. Next one, we are approaching +2 from the left. So +2 is where we want our vertical line. All right, so +2 from the left, we trace this piece from the left. It's coming in here at a y value of 1. So x approaches 2 from the left is 1. Now, the next one, I'm going to go from the right. From the right, hey, it's meeting in the same place. The right limit is 1. That is right here. X approaches -2 from the right. So this is 1. So that's a great date. So the limit at plain old -2 is also 1. All right, and then finally, f of -2. Hey, is there any point? Oh, there is a point right there. Can you see it underneath the 2? That's tricky to see. All right, it looks like there's a little point right there. 2, -1. So right here, f of -2 is -1. Okay. Okay, finding limits using a table. You're just using your calculator here. So in y equals, you put the function. All right, so in y equals, you put 3x squared. All right, to set up your x-axis, right here, you have to hit second and then table. Okay, at the top of that screen, it's going to say table start. TBLS. TART. You want to start your table, you guys, at whatever you're approaching. Okay, so table start is going to be 4 in this case. All right, and then the second row on that table, it just says delta TBL. So this right here, you are in increments of 1/100ths, correct? Yes. So 0.01. All right, so do that right now. Check your values. Pause the video. But you can see in the X column here, I'm getting closer and closer to 4 from the left. I'm getting closer and closer to 4 from the right. So my X's are getting closer and closer to 4. Now what is my Y column doing? Hey, they're getting closer and closer to 48 from the left and from the right. So my limit is 48. The left and the rights are both approaching 48. All right. Okay, for this second example, make sure your calculus is in radians because we have a trig function here. Make sure you put parentheses around your numerator. And then again, tables start right here at 0. Okay, so this is where you start your table. Table start, remember you hit second window, and your delta x here is in 0.1s. Okay, these are going up by 0.1s. Alright, so when you do that real quick, set up your table, make sure you're in radians, pause the video, and fill that chart out, and then we'll check. Okay, so check what you got here. We're getting closer and closer to 0 on the x, but now our y values are getting closer and closer to 0.99. That's pretty darn close to 1. Same thing here, 0.98, 0.99, 0.998. This is getting closer to 1. So that limit is 1. You can also look at the graph and verify. Okay, and finally, the homework worksheet. We have a limit to do algebraically. So the first thing we ask ourselves is, can we do direct substitution? Can I plug in 2 here and here? No, because it causes division by 0. So we can't do direct substitution because we're dividing by 0 if we do. Now we check. Do we have 0 over 0? Yes, we do. 2 minus 2 is 0, so that gives us a 0 on top, or excuse me, on the bottom. And if I plug in 2 here, 2 squared is 4, 4 minus 4. We have 0 over 0, so there is a limit. That's your kind of your clue to factor and cancel so that you can plug it in. So we have the limit as x approaches 2. We're going to leave the denominator alone. This, you got to recognize it, that's a difference of perfect squares. So we factor that like this. 2 binomials, we need x and x. The square root of that first term is the first term in each binomial. We need 2 and 2. The square root of this second term, that last term is the last term, and then our signs are opposite. We need a minus and a plus. All right, this cancels out. Now we have the limit as x approaches 2 of what's left, right here, of x plus 2. And now we can do direct substitution. All right, now direct substitution. That means plug in. So if I plug in 2, 2 plus 2 is 4. So the limit as x approaches 2 of that function is 4. Hopefully that helped. If you're struggling, please get in touch. Email, text, whatever it takes. Find me. We'll talk. We'll get your help. Take care, Calc.